Let's take a look at how these move instructions relate to some C code. So here I've got an exchange function, which takes a pointer to an integer as an argument and also an integer as an argument, and it returns an integer. And what it does is it takes the value out of xp, the old value, and returns it. Meanwhile, it puts y's value into xp. So here's a fragment of assembly code. This is roughly what you get if you compile this program without optimization. The details vary a little bit. It's still roughly the same idea. And what you see at the beginning here is a common thing without optimization, that all the variables in the C program are going to be referenced relative to RBP. We sometimes call RBP the frame pointer, which we'll talk about more when we get to functions. But it happens that at this point that RBP minus hex 18, that is minus 24 bytes, that's going to be the location where XP starts out, and this move Q instruction moves XP into the RAX register. That's XP, it's not the value that XP points to, but XP itself that's going to be in the RAX register. Okay. Then we're going to move Y, the value of Y, into EDX. So that Y variable happens to be stored 4 bytes earlier in memory. So we subtract a larger number here, 28. Notice also that it's a move Q for XP. That's because XP is a pointer, so it takes up 8 bytes, or a quad word. Where Y is an integer that takes up 4 bytes, it's a long word. Reassuringly, this number is 4 bytes smaller than that number. That means there's just enough room for Y right before XP in memory. So we've got the register RAX has XP in it, register EDX has Y. The next instruction says take the value of RAX, then look in memory at that address. So RAX is XP, looking in memory at XP. At the C level, we would write that as star XP. So we're setting ECX to be the value that XP points to, just like up here. So ECX at the moment has, essentially it has the variable x. Meanwhile, we take the value in EDX and put it into memory where RAX points to. So after we get the old value at star XP, we put Y as the new value in star XP. Again, the parentheses here correspond to the star in front of XP. And finally, we're going to move the value that's in ECX, that is the old value of XP, into the EAX register. The reason the code does that is because EAX is generally where we put return values, especially integer return values. So since the C code returns x, that's why it's moving the old value of XP, which is stored in that x variable, into the return register, EAX. Let's try another example. This time I haven't shown you the C code. We'll start with the assembly code and work out what the C code should be. You do have to guess at the beginning here, but you can make some informed guesses. You see we've got 3 pointers. We're unpacking those pointers into different registers. And by looking at what happens later, well, actually you just have to guess. So right now I'm going to tell you that these happen to be in order, that XP, YP, and ZP in this particular case. In other cases, we could make this more clear, the connection between XP and YP, by showing you the full code, but good enough for now. So RDI has XP, RBX has YP, RSI has ZP. Again, those are the values of the pointers, not the values in the pointers. So the next thing that happens is we set EAX to whatever RDI is pointing to. RDI is XP, so that means EAX is becoming the value at star XP. The next line is similar. We look at what RBX is pointing to and put that in EDX. So EDX is becoming, let's see, RBX was YP, so EDX becomes star YP. And finally, as you would expect, we look in ZP, move that to ECX. Right? So this time we have the original values of that XP, YP, and ZP point to in EAX, EDX, and ECX. Next, we move EAX into wherever RBX points to. RBX is YP, so we're setting star YP, and we're setting it to EAX, which is the old value of XP. Next, we move EDX, which is the old value of YP before we set it. Right, and we move it into wherever RSI is pointing to, that is at ZP. So the old YP goes into ZP, and then finally we move ECX, that was, let's see, the old ZP, we move it into RDI, which is XP. So this decode one function is a kind of rotation. It's taking the old y, that should be old z right there, moving x into y, y into z, and z into x.